joint are assembled, it cannot be twisted or wrecked. This makes it very difficult to blow the joint apart and virtually impossible when it is glued. This type of joint is used in the construction of boxes, drawer, cabinets, etc., where the strength is required. The objective of this video is to make you able to mark and make the common dovetail joint at the end of the exercise. So let's begin. Before we begin with the making of common dovetail joint, let us first have the tools ready in hand. The tools which we need to have it ready are marking knife, steel rule, measuring tape, pencil, tri-square, cross-cut saw, bevel edge chisel, mallet, vise or bench vise, jack plane. Let's start. Let's begin by taking two wooden pieces. Cut and trim them to the required size. Step 1. The first stage is to mark out and cut the tail. Place one piece of wood vertically on top of the another as shown here. Draw a line on the horizontal piece A that makes the thickness of the vertical piece B. Now use the marking knife or the marker pencil to mark the dovetail. Step 2. Repeat the same procedure for wooden piece B as done for wooden piece A. Place wooden piece A vertically on top of wooden piece B as shown here and mark the line with the marker pencil. Step 3. Now take the wooden piece A and using a tri-square, let's draw two lines of same thickness marked previously, placing one after the another. Name them 1, 2 and 3. Now using a tri-square, mark an outline at a distance of half the thickness in the first part, that is, in number 1. Let the lines be marked all around the part. Repeat the same marking of 3 equal parts on the other side of the piece A as well. Using a tri-square, mark an outline at a distance of half the thickness in the first part 1. Now divide the line into 6 equal parts, starting and ending with a 1/12th part of distance from the edge. Step 4. Divide the 3 equal horizontal lines into 3 equal parts. Mark the 3 equal points with a pencil. Extend the line straight to the top end grain from the points as marked. Let's now draw sloping lines with a pencil. Join the end of the point as shown from the respective points. Shade the areas which need to be chipped or cut off. Step 5. Fix the piece A vertically in the vise or the bench vise. Cut the shaded area or the walls of the dovetail pin using a tenon saw. Saw on the waist side of the marking cut line. Saw perpendicularly to the sides of the piece and up to the gauge line. Remember to cut a little away from the line so that you can finish off neatly with a chisel later. Chisel out the waist of dovetail spin with bevel edge chisel or firmer chisel. Cut out small pieces of waist until gauge line is reached. Repeat the procedure for the other dovetail pins also. If necessary, clean the dovetail with chisel and mallet. Now the pin is ready. Now let's look at the procedure to prepare the socket. Marking out the socket is the second part of the joint. Step 1. Clamp the second wood piece number B onto the vise. Place the pin members of dovetail A to rest on the socket piece end side as shown. Hold the dovetail pin in the left hand and with the right hand mark out the profile of the dovetail with a scriber or a marker pencil on the socket piece B. Once the marking is done, use a pencil and tri-square to mark straight lines aligned with the dovetail marks. Draw a series of strips to differentiate the waste wood that needs to be cut off. Clamp out the wood piece and cut off the waste wood with a coping saw. Step 2. Clean the dovetail with chisel and mallet until you have smooth finish. It should look like this when you're done. Now fix the two dovetail A and B as worked with the help of a mallet. If the fit is tight, trim it with a bevel edge chisel and remove excess material. After it is perfectly fit, use a tri-square to check whether the pieces are at 90 degrees with each other. Now you have the common dovetail made ready. Let's quickly recap. In this video, we have learned how to make a common dovetail joint and also the simple technique to make it. Hope you have understood everything taught in this session. See you in another video. Thank you and goodbye until then. Hello trainees. Today we are going to learn about making the lapped dovetail joint. The objectives of this video are: after this session, you'll be able to gathering equipment needed to make lapped dovetail joint, making the lapped dovetail joint, advantages and application of lapped dovetail joint. Let's start. Gathering equipment needed to make lapped dovetail joint. Wooden piece of dimension 70 × 40 × 275 mm, 2 numbers. Jack plane, marking knife, bench vise, mallet, tenon saw, bevel edge chisel, measuring tape, tri-square, smoothing plane. Making the lapped dovetail joint. Check the wooden pieces using folding rule. Plane it to the required size of 70 × 20 × 225 mm. Let's name them as A and B. Mark and cut the plank lengths of 200 mm, 2 numbers. Saw off the waist end and finish it to square. Then we need to mark the dovetail pin on the wooden piece A. To mark the dovetail pin, we are going to follow the following steps. Let's first take a look at the drawing. Now let's mark the lines shown in this drawing on the wooden workpiece A. Let's first draw the line P, that is 15 millimeters away from the edge of the wooden piece. Next, let us draw a line that is in between this line and the edge. Now let's make the 10 millimeters and 20 millimeters marking along the edge of the wooden piece. Let's now take a look at the next drawing. Draw a line at a distance of 15 millimeters from line P. Label this region between the two lines as 2. Now draw another line at a distance of 15 millimeters away from the new line we just drew. Name the area between these lines as 3. Now separate the new line into 3 equal parts. With tri-square and the scriber, mark only the lines indicated with thick green lines as shown on the drawing. Use the marking knife or the mark pencil to mark. Then the regions inside 1 and outside the 20 millimeters lines can be shaded using a pencil. Now we need to make the dovetail pin on the wooden piece A. To make the dovetail pin, we are going to follow the following steps. Fix the piece A vertically in the vise or the bench vise. Cut the shaded area or the walls of the dovetail pin using a tenon saw. Saw on the waist side of the marking outline. Saw perpendicularly to the sides of the piece and up to the gauge line. Remember to cut a little away from the line so that you can finish off neatly with a chisel later. Chisel out the waist of dovetail pin with a bevel edge chisel or firmer chisel. Cut out small pieces of waste until gauge line is reached. Repeat the procedure for the other dovetail pins also. If necessary, clean the dovetail with chisel and mallet. Now the pin is ready. Now we need to mark the dovetail socket on the wooden piece B. To mark the dovetail socket, we are going to follow the following steps. Clamp the second wood piece number B onto the vise. Place the pin members of dovetail A to rest on the socket piece end side as shown. Hold the dovetail pin in the left hand and with the right hand mark out the profile of the dovetail with a scriber or a marker pencil on the socket piece B. Draw a series of strips to differentiate the waste wood that needs to be cut off. Mark the side and the depth till which the wooden piece B has to be cut. The depth should be equal to the depth of the wooden piece A, so 20 millimeters. Now we need to make the dovetail socket on the wooden piece B. To make the dovetail socket, we are going to follow the following steps. Clamp out the wooden piece and cut off the waste wood with a tenon saw. Clean the dovetail with chisel and mallet until you have smooth finish. It should look like this when you're done. Assemble the pieces together properly. Check the joint for the squareness and evenness using tri-square. Advantages and application of lapped dovetail joint. Carpenters use dovetail joints to create cabinets, furniture, drawers, log buildings, car case construction, timber framing. Dovetail joints are known for their strength and durability. Let's quickly recap. In this instructional session, participants will learn to create a lapped dovetail joint. The video covers equipment gathering including wood, jack plane, scriber, bench vise, mallet, tenon saw, bevel edge chisel, steel scale, measuring tape and tri-square. The tutorial guides through checking, planing, marking, cutting and assembling the joint. For the dovetail pin on piece A, dovetail joints find applications in carpentry for their strength and durability in creating various structures. Hope you understood everything taught in this session. See you in another video. Thank you and goodbye until then. Hello trainees, today we are going to learn about making the rebate butt joint. The objectives of this video are, after this session you'll be able to gathering equipment needed to make rebate butt joint, making the rebate butt joint, advantages and application of rebate butt joint. Let's start. Gathering equipment needed to make rebate butt joint. Wooden piece of dimension 80 x 20 x 450 mm, 2 numbers. Jack plane. Marking knife. Bench vise. Rebate plane. Steel scale. Measuring tape. Tri-square. Smoothing plane. Wood glue. Bench stop. Making the rebate butt joint. Check the wooden pieces for its size. Use measuring tape for checking the dimensions. Plane it to size of 80 x 20 x 450 mm, 2 numbers using jack plane. Hold both the planks side by side in a carpenter's vise. Then mark a section of width 20 mm throughout the length of both the wooden pieces. Then mark a depth of 10 mm along the sides that were marked in the previous step. We should get wooden pieces as marked in the diagram. Keep the marked plank against the bench top on the workbench. Take a rebate plane of adjustable type and make the rebate on both sides. Check its squareness and flatness of the rebate with tri-square. Repeat all the previous 3 steps on the other piece of wood as well. Keep both the planks together and check its alignment. Apply glue on the rebate part of both the planks and fix both the planks along its rebate. Just move to and fro to spread the glue evenly and clamping. Allow glue to dry. Remove the clamp. Once the glue has dried, finish the joint using smoothing plane. Facts about rebate butt joint. The rebate joint is usually used as a corner joint because rebate joint in itself is quite weak. It is usually strengthened with nails, screws or staples. These strengtheners also bind the joint while the glue is hardening. It is also possible to use dowels as strengtheners if the dimensions of the joint allow that. Application of rebate butt joint. It is used in a variety of projects including widened joints, framing, card case construction, timber paneling, securing 2 narrow pieces together, corner joints. Let's quickly recap. Gather equipment. Collect tools like wooden pieces 80 mm into 20 mm into 450 mm, a jack plane, bench vise, rebate plane, measuring tape and wood glue. Prepare wooden pieces. Plane the wood to the specified dimensions. Mark a 20 mm section along the length of both pieces and a 10 mm depth on the sides. Create the rebate using an adjustable rebate plane. Assemble the joint. Align both planks. Apply glue to the rebate and fix them together. Clamp and allow the glue to dry. Finish the joint with a smoothing plane. Advantages include simplicity, gluing ease, weight distribution, support, reduced splitting, and versatility for smaller projects. Hope you understood everything taught in this session. See you in another video. Thank you and goodbye. Until then. Hello trainees. Today we are going to learn how to make glued butt joint with dowel. The objectives of this video are: after this session you'll be able to gathering equipment needed to make secret pocket screw butt joint, making the rebate butt joint, advantages and application of secret pocket screw butt joint. Let's start. Gathering equipment needed to make secret pocket screw butt joint. Wooden piece of dimension 90 mm into 20 mm into 450 mm, 2 numbers. Jack plane, pencil, T-clamp, mallet, firmer chisel, 35 mm into 8 mm screws, 3 numbers. Tri-square, ratchet brace, screwdriver, straight edge. Measuring tape. Making the secret pocket screw butt joint. Check the dimensions of the 2 wooden pieces and make sure that it is of the size 90 mm into 20 mm into 450 mm. If not, then plane it until we reach the required size. Mark the distances 50 mm, 225 mm and 400 mm along the gauge line, squaring the position of the screws across both pieces using a tri-square and pencil. Make 3 pilot holes of diameter 2 mm at 50, 225 and 400 mm as shown in the sketch to a depth of 25 mm using hand drill. Fix the 35 into 8 screws on the pilot hole and drive it to a depth of 25 mm on the plank using a screwdriver. The length of the screw above the wood in plank B should be slightly less than the depth of hole in A. Adjoining the hold mark for a slot of size 10 mm into 8 mm into 20 mm on the right side of the hole. Chop off the slot wood layer by layer using firmer chisel up to the required thickness. Assemble the plank so that the screw head of plank B enters the bore of plank A. Clamp parts A and B at equal levels. Tap gently the part B to the left using T-bar clamps. If both parts are in order, remove the clamp and finish the fitting. Check the flatness of the plank using the straight edge as per the drawing. Advantages of using secret pocket screw butt joint. Pocket screw joints allow for rapid and ease of assembly. Pocket screw joints are stronger than simple butt joints, so more strength and stability. An alignment clamp ensures flush joints without complex measurements. Application of secret pocket screw butt joint. Face frame construction. Table aprons. Drawer box. Utility cabinets. Wooden furniture. Let's quickly recap. To make a secret pocket screw butt joint, take 2 wooden planks. In the first wooden plank, mark them for drilling and drill pilot holes of 2 mm diameter. Insert 35 mm by 8 mm screw, driving them 25 mm deep into the plank. On the other wood, create a slot of 15 into 10 into 20 mm adjacent to the hole. Gradually chisel the slot to match the screw thickness. Place the wood with the slot onto the one with the screw. Clamp them together and use a wooden mallet to align them, and then remove the clamp and check for its flatness. Hope you understood everything taught in this session. See you in another video. Thank you and goodbye until then. Hello trainees. Today we are going to demonstrate first aid methods and learn about basic training. The objectives of this video are: after the session you will be able to rescue the victim from electric shock, resuscitate the victim by Nelson's arm lift back pressure method, resuscitate the victim by Schaeffer's method, resuscitate the victim by mouth-to-mouth method, resuscitate the victim by mouth-to-nose method, resuscitate the victim who is under cardiac arrest, CPR, cardiopulmonary, treatment for victim who is bleeding, using fire extinguisher to put out fires, Practice on workshop safety and discipline. Let's start. Rescue the victim from electric shock. Loosen clothing that may interfere with victim's breathing. Remove any object, including false teeth, from his mouth. Bring him to the ground level. Start artificial respiration immediately. Call for a doctor. Resuscitate the victim by Nelson's arm lift back pressure method. Place the victim as shown. Kneel such that your knees are near the victim's hands. Place your hands on the back of the victim. Gently bend forward, keeping your arms straight until they are nearly vertical and steadily pressing the victim's back. When bending back, your hands should slide down the victim's arms and grasp his upper arm just above the elbows. When you bend back completely, pull the victim's arms towards yourself gently. To complete the cycle, lower the victim's arms and move your hands back to the initial position. Do this until the victim starts breathing naturally. Do not give him any stimulant until he is fully conscious. Resuscitate the victim by Schaeffer's method. Place the victim and kneel over them as shown. Victim's thighs should be between the rescuer's knees. Place the hands and fingers as shown. Gently bend forward, keeping your arms straight until they are nearly vertical and steadily pressing the victim's back. This forces air out of the victim's lungs. When you bend back completely, remove all the pressure on the victim. This allows air to fill up back into the lungs. After 2 seconds, swing forward again and repeat the cycle 12 to 15 times a minute. Do this until the victim starts breathing naturally. Resuscitate the victim by mouth-to-mouth method. Place the victim as shown. Tilt victim's head back. Use your fingers to position the upper and lower jaws as shown. Take a deep breath and place your mouth over the victim's mouth as shown, making airtight contact. Close the victim's nose. If you dislike direct contact, place a porous cloth over the victim's mouth. For an infant, place your mouth over his mouth and nose. Blow into the victim's mouth gently in case of an infant until his chest rises. Remove your mouth and release the hold on the nose to let him exhale, turning your head to hear the rushing out of air. The first 8 to 10 breathings should be as rapid as the victim responds. Thereafter, the rate should be slowed to about 12 times a minute, 20 times for an infant. Resuscitate the victim by mouth-to-nose method. Use this method if the victim's mouth will not open or has a blockage you cannot clear. Use your fingers to shut the victim's lips. Firmly place your lips around the nostrils and breathe into them. Note if the victim's chest is rising and falling. Repeat this 10 to 15 times until the victim responds. Continue this exercise till the arrival of the doctor. Resuscitate a victim who is under cardiac arrest. Check quickly whether the victim is under cardiac arrest. In cases where the heart has stopped beating, you must act immediately. Cardiac arrest could be ascertained by the absence of the cardiac pulse in the neck, blue color around lips, and widely dilated pupil of the eyes. Lay the victim on their back on a firm surface. Kneel alongside facing the chest and locate the lower part of the breastbone. Keeping your arms straight, press sharply down on the lower part of the breastbone, then release the pressure. Repeat the previous step 15 times at the rate of at least once per second. Check the cardiac pulse. Move back to the victim's mouth to give true breaths, mouth-to-mouth resuscitation. Continue this cycle of 15 chest compression followed by 2 breaths. Check the pulse frequently. Stop the compression if the heartbeat returns and stop the mouth-to-mouth breathing if natural breathing returns. Place the victim in the recovery position as shown. Keep him warm and get medical help quickly. Treatment for bleeding victim. Determine the location of the bleeding. Elevate the injured area above the heart if possible. Apply direct pressure to the bleeding area with a sterile cloth. Keep the pressure on for 5 seconds. Check to see if the bleeding has stopped. If not, apply further pressure for 15 minutes. Clean the wound. Bandage the wound with a pad of soft material. Advise the victim to take treatment from the doctor. Use of fire extinguisher. Alert the people around you when you see fire by shouting, "Fire, fire, fire, fire." Then immediately inform fire service. Tell the people to go away using the emergency exits. Put the electrical power supply in off position. Do not allow people to go near the fire. Identify the type of fire. Refer Table 1. Assume the fire is B-type. Select CO2, carbon dioxide, fire extinguisher. Check for its expiry date. Break the seal. Pull the safety pin from the handle. Aim the extinguisher nozzle or hose at the base of the fire. This will remove the source of fuel fire. Squeeze the handle lever slowly to discharge the agent. Sweep side to side approximately 15 cm over the fuel fire until the fire is put off. Practice on workshop safety and discipline. Switch off all the machinery and equipment before starting the cleaning process. Use a mask to cover the mouth and nose. Identify the areas, equipment, machine that needs to be cleaned. Keep the movable items in one place and group them. Clean the dust carefully without damaging any part or connection in the machine or equipment using a cloth. Use wet dusting cloth on areas that are wired. Remove rust on the parts of the equipment or devices using an emery sheet. Do not remove lubricants in the machine while wiping or cleaning. Use vacuum cleaners to suck dust from the areas where a brush or cloth cannot help. Collect the waste materials found in the lab and put it in the specified dustbin. Clean places where grease or oil has been spilt on the floor. Put all the materials and equipment used for cleaning in their respective places. Inspect and ensure that all machines are working after cleaning in the presence of the instructor. Discuss abnormal things that you came across while cleaning with the instructor. Prepare report if the instructor asks for it. Recap. In this video, we learned crucial first aid and basic skills covering electric shock rescue, resuscitation methods, cardiac arrest response, bleeding treatment, fire extinguisher use, and workshop safety. This video emphasizes practical techniques for immediate response. Hope you understood everything taught in this session. See you in another video. Thank you and goodbye until then. Hello trainees. Today we are going to identify different wooden sample pieces for hardwood, softwood, grains and their applications. The objectives of this video are: after the session we'll be able to identify the different wooden sample pieces and their applications, to identify the hardwood and softwood, to identify the growth and grains. Let's start. Teak wood. It grows in a large tree. Wood is straight-grained and has a rich brown-yellow color. Sapwood is pale yellowish and heartwood is golden brown. Hard and heavy wood weighing about 650 kg per cubic meter at 12% moisture content. Uses of teak wood: shipbuilding, furniture crafting and cabinet making. This wood is called Devdar. It is found in straight tall trunk with short branches and pointed leaves. Typically found in altitudes ranging from 1200 to 3000 meters. The tree features a lofty straight trunk with small branches. Sapwood is white and heartwood is light yellowish brown. The wood is hard and heavy with an average weight of 545 kilograms per cubic meter at 12% moisture content. Exhibits a medium fine and even texture. Devdar is a non-porous wood, meaning they do not have as many vessels within the wood fibers. Uses of Devdar: construction purposes, furniture, packing cases, railway sleepers, carriages, etc. Shir. Shir looks similar to Devdar but of inferior quality. Sapwood is white and heartwood is light yellowish brown. Hard and heavy wood with an average weight of 575 kilograms per cubic meter. Exhibits a medium and uneven texture. Grain pattern ranges from straight to spiral or twisted. Uses of shir: construction purposes, furniture, big size of packing cases, cabinet making. Kale. Kale is an evergreen tree with similar structure to shir. Sapwood is white and heartwood is light and pinkish red. Closely grained, hard and durable wood. Exhibits a resinous color when freshly cut. Soft and light with an average weight of 515 kilograms per cubic meter. Uses of kale: cabinet making, furniture, packing cases, drawing boards, railway sleepers, etc. Shisham. Shisham typically grows along roadsides. Tree with a short trunk and large branches. Sapwood of siso is pale yellowish and heartwood is golden or dark brown. Hard and heavy wood with an average density of 780 kilograms per cubic meter. Exhibits a medium coarse texture with a fairly straight interlocked grains. Sal. Straight growing upright tree. Sapwood is pale yellowish and heartwood is brown or reddish brown. Hard and heavy wood with an average density of 855 kilograms per cubic meter. Exhibits a coarse texture with an interlocked grains. Uses of sal: it is a valuable timber and recommended for all. Construction purposes, railway sleepers. Babul. Babul characteristics: note that the leaves of this tree are very small. Also note that the trunk of the babul is relatively small, so the wood from babul is not available in large shapes. Abundantly found throughout India. Wood has a closed grain and is tough. Wood color is pale red. Weighs approximately 785 kilograms per cubic meter. Uses of babul: tool handles, wheels, bodies of carts, plows, etc. Mango. Mango trees are found all over India. The wood is of inferior quality, coarse and open-grained, meaning it has large pores. The color of the wood is yellowish grey and weighs about 690 kilograms per cubic meter. It contains a large amount of moisture and sap. Uses of mango: inferior quality doors and windows, packing case, etc. Bamboo. These trees are found in practically all the parts of India. It is a flexible and strong material. Bamboo grows naturally on soils which are neither too acidic nor too alkaline. The greater concentration of bamboo is, however, found in Assam region. It is used for making the poor man's hut all over the country. Uses of bamboo: walls, flooring, ceiling, roofing ladder, basket-making mats, walking sticks, umbrella handle, toys, paper pulp. Defects in timber: Natural defects occur in all kinds of timber depending upon the soil upon which they grow and climatic conditions due to which they are subjected while growing. A defect in any irregularities occurring in or on the timber. Defects reduce strength, durability, and so utility value of the timber. Causes of these defects are lightning, strong winds, fires, diseases, insects, fungi, etc. Carelessness while felling, that is when cutting down the tree. Seasoning, that is letting the cut wood to dry. Conversion, that is during the process of turning a log into a pile of usable planks or boards. Fungi and insects. Let us look at some common defects. Let's first look at burls. Due to some injury or irritation of the trunk, an abnormal growth are formed on the side of the tree. This is called burls. Case hardening. Case hardening is a condition of the outer layer of timber that is abnormally hard. This is caused by complete seasoning and the outer layers are dried too quickly. Collapse. A flattening of the cells may be due to excessive or uneven drying. This may be prevented if drying in low temperature. Bowing. A curvature from the plane along the wide surface of the board. This is caused due to uneven shrinkage and uneven drying during seasoning. Board not being out parallel to the growth rings. Cupping. A simple curvature across the width of the board due to greater shrinkage on the concave side. It is more pronounced in back sawn boards. Spring. A curvature along the edge of the board not affecting the face, remaining flat, caused by uneven shrinkage and poor drying of the timber. Twisted fibers. This defect is due to the tree being twisted constantly in one direction by the force of prevalent wind. A spiral distortion along the length of the piece of timber. This may be caused by uneven shrinkage due to uneven drying. Let us look at cupping, bowing, spring, twist all together. Upsets. This is the fracture of the fiber across the grain and may be the result of injury in felling. Grain refers to the direction of the cells and vessels of the wood. Cross grain. When the wood has varying inclinations to the axis of the wood piece due to cutting from timber in which the straightness of the grain is imperfect. Diagonal grain. When the fibers in the wood do not run parallel to the axis of the wood piece even though it was cut from straight grain timber. This is caused by cutting parallel to the axis of the log instead of parallel to the bark. Interlocked grain. When the fibers of adjacent layers of the wood being spirally inclined in opposite directions, this grain surface is difficult to plane. An example of this is the Queensland maple, which gives ribbon stripe figure. Spiral grain occurs when the fibers have taken a spiral course in the tree trunk as if the tree has been twisted. The cause is not definitely known. Wavy grain. A wavy arrangement of the fibers, also known as curly or fiddleback grain. This grain surface is difficult to place and work. Veiny edge. This defect lies in the sapwood which accompanies vein due to economical conversion of logs. Rind galls. These peculiar curved swellings are found living on dead trees, generally caused by the growing of the layer over the wounds left after the branches have been imperfectly cut off or removed. Wind cracks. These are shakes or splits on the sides of a bark of timber due to the shrinkage of exterior surface exposed at atmospheric agencies like sun and wind, etc. Recap. First, we looked at different types of trees which gives us wood like teak, devdar, chir, kale, shisham, sal, babul, mango and bamboo. Then we saw the types of defects. Hope you understood everything taught in this session. See you in another video. Thank you and goodbye until then. Hello trainees. Today we are going to identify annual ring, knots, shakes and checks in the given images. The objectives of this video are: after the session you'll be able to identify the name of annual ring, to identify the name of knots, to identify the name of shakes, to identify the name of checks. Let's start. Knots. Knots are caused by a branch or limb being cut through during the process of sawing up the log. They may live or dead, but they break the continuity of fibers. Next, we look at loose or dead knot. Loose or dead knot, left by branches that have been cut off or broken before sawing down the tree. This will leave a dead knot when it is cut. It is loose in position on the surface of the piece. It cannot be relied on to remain in position in the piece. Live or sound knot. It is left by a branch when the tree is felled. It is solid across its face and hard as the timber surrounding it, and it is free from decay. Knots are considered to add beauty and effect in the final appearance. Shakes. Shakes is the partial or complete separation between adjoining layers of wood. This is due to the relief of growth stresses present in the stem at the time of felling. Heart shake. These are the cracks or splits in the center. Starting from the pith and extending in the direction of the medullary rays in one or opposite directions towards sapwood. Such defects are found in over matured trees, but sometimes they may be caused by quick drying of the central part of the tree. This defect is caused due to shrink of heartwood. Star shake. These are crack or split which extend from bark towards sapwood. This defect is caused when the tree is subjected to serve heat or frost during its growth. The width of these cracks or shake is more at the outer ends and reduces when they extend towards center. We can see that here. Cup shake or ring shake. These are found by the rupture of tissue in a circular direction across the cross section of a log. It forms usually along the annual rings. Radial shake. These are similar to star shake, but it occurs due to exposure to sun when felled timber is placed for seasoning. Many cracks or split run for a short distance from bark towards center, then follow the course of an annual ring and lastly go towards the center radially. When the rupture extends only a part round, it is called cup shake. When the whole way round or almost so, it is called ring shake. This defect is caused either due to unequal growth or due to sudden contraction for timber under atmospheric changes assisted by twisting action due to wind. Let us look at heart shake, star shake, cup shake or ring shake, radial shake together. Check. Check is the separation of the wood extending for a few inches or centimeter along the grain and formed while drying. End check, occurring on the end of the piece of timber. Internal check, occurring in the interior of the piece. Surface check, occurring on the surface of the piece. Through check, on which extends through the piece from one surface to the other. Here is a glance of all the checks together. End check, internal check, Surface check, through check. Decay. When timber is kept in a place which has alternating dry and wet conditions, or when used in a dark, unventilated position. These alternating conditions make the timber vulnerable to diseases like dry rot and wet rot. Dry rot. Dry rot occurs when there is improper ventilation. Because of improper ventilation, there is growth of fungus which eats the fiber of the timber and reduces them to power. The process of dry rot is accelerated by the growth of fungus, but the origin of the disease is due to the decomposition of the sap in the timber. The food for the growth of fungi is supplied by this decomposition. Tremendous destruction of the timber is caused by this highly infectious disease. This disease may develop in seasoned timber or unseasoned timber treated with preservatives. This disease is common in warm cellars, basements, ends of timbers built into walls. This disease can be detected by tapping at one end of the timber, post or log and hearing the sound on the other end. If a distinct sound is heard when tapping, then it indicates a good timber, and if it is a dull sound is heard, then it is a sign of a decayed or diseased timber. The following method can be adopted to prevent or eradicate this disease by allowing free circulation of free air. Portions of wood attacked by dry rot should be cut off and the remaining portion painted with copper sulfate. Expose the infected portion to sunlight and cleaning of fungus. Wet rot. This disease is the result of decomposition of timber caused by damp and moisture. This disease is further accelerated by alternate dry and wet conditions. The portion of the timber attacked by wet reduces to grayish-brown powder. In this disease, the timber is just decomposed while wet and then it scales when it dries. This disease can be developed in timber whether dead or alive. All types of timber used or kept in uncovered situations is likely to be exposed to rain and hence subjected to wet rot. By removing sap from timber through seasoning first and then treating it with preservatives, wet rot can be prevented. Diseases. When timber is set to decay, its value as an engineering material becomes less. When timber is subjected to excessive defects, diseases or attacked by insects, it deteriorates in strength. These insects damage their appearance and reduces their strength. The following insects generally attack the timber. Pinhole borers. They attack the standing tree or recently felled timber. Powder post beetles. They attack timber while it is stacked for seasoning sale or awaiting use for years. Termite or white ants. They attack timber used for structural purposes in buildings, bridges, poles, sleepers, fence posts, etc. The following are the various causes of decay. Alternate dry and wet conditions. Improper stacking storage of timber. Improper seasoning or unseasoned timber. You can see this in this video. The wood can be easily affected by rain. Use of unseasoned timber treated with preservatives. Use of seasoned timber without treating it with preservatives. Different types of insects. Development of defects during growth conversion, improper use, etc. Improper position of structural member of timber. Development of timber disease. Effect of natural agencies. Recap. In this video, we looked at defects in timber like knots, which are of two types, live knot and dead knot. Then we looked at shakes and its four types being heart shake, star shake, cup shake and radial shake. Hope you understood everything taught in this session. See you in another video. Thank you and goodbye until then.
Today I am giving presentation on joint in concrete pavement. So we will start with the definition why the joint in the concrete pavements is required. Joint are provided in cement concrete road for expansion, contraction and warping of the slab due to the variation in the temperature of slabs. Variation in temperature and moisture content can causes volume changes and slab warping, which may causes significant stresses.